Hello guys, in this Python class we will be discussing topics about iterators. We'll be discussing iterators. One second guys. We'll be discussing iterators and generators, right? So yeah, let's begin the class. Today we are going to understand a very important concept that works behind every loop in Python, right? Whenever we write a for loop, and Python gives us values one by one after these for loops get executed, something is happening internally. That mechanism that makes this possible is called as iterable iterator. Sorry, the mechanism that makes this happen is called as iterator. So what is an iterator? An iterator is a special tool in Python that gives values one at a time from a collection such as list, strings, or tuples. Right? Instead of giving all values at once, it gives the first value, then the next, and so on. So this one by one system is useful because it saves memory and allows Python to work with large data sets without loading everything at once, right? So that's the benefit of using iterators. So now let's try to understand what is an iterable. Before getting into iterators, it is important to understand what is an iterable, right? So an iterable is anything that can be looped over, right? Example of iterables can be list can be looped over, tuples can be looped over, strings can be looped over, and ranges can also be looped over, right? So all these are called as iterables. These objects contain multiple values and can be used inside the for loop. So now converting an iterable into an iterator. Let's understand this concept. So Python provides a built-in function called iter. This function, what it does is it takes an iterable in it and returns an iterator from it. So now let's try to understand that with an example. Right, now let me take a iterable, let's say a list, a numbers list. I have let's say I have 10, 30, 50 and 70 in my numbers list, and normally here using the iter function iter, and then I'll be passing these numbers list as an argument, and then I'll be assigning it to a value here. I'll try to explain this code very soon. So here numbers is a list, it's an iterable, and it is an iterator created from this list. So the function iter is a normal built-in function in Python. It is not a class. It simply takes a iterable and gives back an iterator object. So now how to get values one by one using this system. So for that we have a function called next. Once we have an iterator, we can take value from it one at a time using the next function. So example here, we have the numbers list. Numbers list is passed as an argument to this iter function, and we created an iterator object and we are calling it as it. Now if I pass this it in this next function and if I print it out, right, if I print it out, let's look at the result. The result is 10. So what is happening here? What is happening, guys? Each call to the next it asks Python for the next value from the iterator. The first call is asking Python to give 10 from this iterator, right? 10 from the iterator, or sorry, iterable. List is an iterable. So list is an iterable. It is passed to an itr function, and this gave us the iterator, and from the iterator this next function is asking Python for the value from the iterator, the first value, the second value, the third value. Now since I use the next function for first time, it gave me 10. Now if I use it for the second time, the same code, the same line, if I use it for second time, what is happening? It is giving me the next item from the iterator, right? 30 from the iterator. If I use it for third time, it gives me 50, right? It gives me 50. Now if I use it for fourth time, then it gives me 70, right? 70. So if we call next iterator again after all elements are finished, now let's say we have 4 elements and 4 times I printed the next function, and we got all the 4 items from this list, right? So what if I write this again, if I call this again, the next function, if I try to call it again, next it, what is happening is, it says stop iteration. The error is the stop iteration error. This simply means there are no more values left to give, right? So in general, how Python's for loop uses an iterator internally. Let's try to understand that. Now let's say we have something called for x in numbers. Let's print out this x. What we generally get here? Python does not directly takes all values from the list. Instead, Python secretly does the following steps here. What it does is, once it looks at this for, what it does is, it calls the iter function, iter function, to create an iterator. It repeatedly calls the next function on that iterator to each value. All this is happening in the backend, right? So when there are no more values, Python automatically stops the loop. So this is what happening every time we use for loop. We are actually using an iterator behind the scenes, right? So that's a small concept about iterator. This is an extension to the functions concept and for loop concept that we discussed in our live classes. So yeah, now let's discuss about generators. Generators is internally connected to iterators. Let's try to understand what generators are now. So a generator is a special type of function that gives value one at a time, just like an iterator. But instead of using next function manually or creating a class, generator, what it does is, it uses a special keyword called yield. A generator looks like a normal function, but instead of returning all values at once, it returns one value at a time whenever the function is paused or resumed. So why do we use generators in normal cases? Generators are useful because they save memory. I'll try to explain these generators with an example, but before that, let's understand what is the purpose of a generator. What are the uses? So they do not create the entire result at once. They save the memory, and they work very well with large data because they are conserving the memory, and they automatically create an iterator behind the scene. So they make code simple and clean, right? So a generator is the easiest way to create a custom iterator. Now let's try to understand the keyword here. To create a generator, we use the keyword called yield. We use a keyword called yield. Yield instead of return. Return in general ends the function completely. If you understand the functions concept, in our previous class we discussed about the return statement. What is the purpose of return? Return ends the function completely. It returns something out of the function's output, right? Something out of the processing that happened inside the function. So return ends the function completely. But what here yield is doing is, yield gives one value and pauses the function. So there is a difference. Return ends the function completely, and yield gives one value and pauses the function completely. The next item, the generator, is called the next time the generator is called, it continues from where it left off. Now let's try to understand this with an example. Let me create a new file, quick new file. I will call it as a second lesson.py. And here is how we will be using yields number from 1 to 3. Let's write a function def. I'll call it as my generator. This is the function that we want to create, and I'll start using with yield keyword. Now if I write yield keyword here, and then if I write 1 and then again yield keyword, what this does I will be explaining you in few seconds. Just follow the code. So when we call the function, it does not return it does not run immediately. When I call this my generator function from now, it does not run immediately. Instead, it gives us generator object. Now let's try to call this function and check the output. I'm calling this function here. If we had something called return here, we would have been seeing output here, right? So but here when I call this my generator, nothing is happening here, right? So now what I'll be doing is I will be creating a generator object, and then I will be printing this value one by one. We use I will be using next function to get values one by one. So here print, and then I'll be using the next function, and then I will be using gen here, right? So now if I run this code, what happens? It prints out the first yield, and then if I use this again, if I copy paste this again and use it again somewhere in my code, what it is doing, it is pausing the function for a while and it is returning only one value. Next, if I try to use this for second time, it starts from where it left, right? That is from second, right? From second. And now if I try to print it once again, it is pausing the function and it is waiting for the next function once again. Now if I try to run this, it gives me 3 again, right? So after all values are done, what I'll be getting, right? Let's try to print this again once and see. Again we get a stop iteration, right? We get a stop iteration. So generators automatically becomes iterators. A generator function automatically creates an iterator. This means generator can be used inside a for loop. No extra code is needed. No class or next method is needed. Python handles everything internally. So I'll show you an example here. Let's create a new lesson again, 0, and save it as .py. Here let's write a for loop, but now instead of any normal iterator, let's use the function that we created. Let me copy this function here and let's paste it out, and then I'll be using a for loop here for value in the function that I created. So I'll be using this as iterable, and then I'll be printing out all the values. So this will act as an iterable now. My generator will act as an iterable, and let's see what the end result will be. 1, 2, 3, right? So each loop iteration automatically calls the generator and gets the value, gets the next value. So a practical generator, let's try to create a practical generator example here. I'll leave some empty space with a print function here, and then I'll try to create another function called even numbers, and I'll take one parameter here. I'll name it as limit, and I will be creating a variable and will be assigning a 0 to it, and then I will write a while loop now. I will run a while loop while num is less than or equal to let's say the given limit from the function. Here I will try to yield number from here. yield num, right? And then in the next line, since we are trying to print out even numbers in the given limit, I will say num is equal to num plus 2, right? Num is starting from 0 and 0 plus 2 will be 2, right? Again 2 plus 2 will be 4, again 4 plus 2 will be 6. All the numbers from here we will be yielding even numbers, right? So let's now try to run a for loop on it. For and in even numbers, I'll be passing an argument called 10 here, right? And if I print out n, if I print n here, what will be the output? Any guesses? I'll be getting all even numbers till 10. This yield is yielding all the numbers, and then this logic is adding 2 to that number and will be passing all the even numbers to me. Let's see here. It starts from 0, right? It starts from 0 and then 2 is an even number, 4 is an even number, 6, 8, 10, right? If I pass 100 here, it will give me all even numbers till 100. One second, see, all the even numbers till 100 are given to us in the terminal. So that's how we use yield keyword in the generator. So let me try to explain this once again to you. The generator here starts at num 0, yield 0, and then each yield returns the next even number, right? Each yield from here, once the 0 is yielded, then 0 will be added with 2 and it will be saved, it will be aligned to assigned to this number num variable, and again this num variable is lesser than the limit passed, that is 100. So this num variable will be yielded, that is 2, and then again 2 plus 2 is 4. 4 is lesser than the 100, so 4 will be yielded. The same continues till 10, right? So when called again, it continues from where it left off. So this is a clean memory saving way to produce sequences of numbers. So now you might ask, what is the difference between a return and a yield? The difference between return and yield, right? Yield. So here, a return statement, when used in the function, it ends the function. It ends function, whereas yield, it pauses the function. It pauses the function, and then return, it gives back one final value, right? Gives one final value, whereas yield, it gives back one value each time, one value each time. And whereas the return, it cannot resume. It cannot resume. Once it gives the value, we cannot resume it. Whereas yield, once it gives the value, it can resume from where it paused. Resume from where it paused, right? If you remember, the first one, it pauses. It has the ability to pause the function. So now it also have the ability to resume the function from where it paused. Now here, return, it does not produce any sequences. No sequences are produced in the return. It might return a list or return a set, but it cannot produce a sequence. Whereas yield, ideal for sequences. The main purpose of yield is to give out the sequence. Ideal for sequences. And so yeah, that's the difference between return and generator. So try to understand it because we'll be using yield frequently when we start working on our real-time projects. So a generator function can have multiple yields, but normally one return value. This is the main difference as well. So so this is the difference between return and yield. Now let's try to understand. Now let's try to work on another example where we will be creating a infinite generator. This will be quite interesting, so focus here. So here generator can produce endless sequences without storing them in the memory. So that's one big part of using the generator in our code. Now let's try to understand how to develop that code. Now let's say let's define a function first and call it as numbers all numbers, and then so let's there is an so there is a typo while creating the file. Yeah. So here I will be assigning, I will be taking a variable num and will be assigning 1 to it, and then I'll run a while loop. While the condition is true, while the condition is true, yield num, and after yielding num, increment it by 1. Right? So this is what this generator will never end. This generator will never end because the while condition is true. So whatever the logic is written inside, it keeps on yielding the number unless it is breaked upon, right? So here, since I am not using break statement, and since this is the condition is also not false, what happens is the generator never ends. Python does not crash because it gives only one number at a time. So this concept of creating an infinite number, so we tried it in while learning while loop. So if you remember, when there is a condition true and if there is no break, then we have a infinite system created, right? Infinite number of infinite times the number is being repeated now. But with case of generator, that is not usual. So here it will yield one number at a time till infinite. So let's use it carefully here. Let's now try to create an object gen and then assign this all numbers. And now let's try to print gen within the next function. So now let's see the output, right? 1. So it keeps on as many next statements I print, it keeps on printing the value, printing the number, right? Till 6. There is nowhere I mentioned 6 in the argument or in the parameter or within the code. So it just prints me the number of times I write I try to print the next statement, right? Now let's see. So there is an error here. Okay, sorry. Let's try to. Yeah, that's the main concept, guys, of the generator creating the infinite thing. So if I run it, see till 20. So this is how I make use of, we can make use of generator. So the real world use cases of generators are used when you want to process large files line by line, right? And you want to generate long lists of numbers without storing them in memory. And you also want to stream data from the internet. You want better performance in loops. To want a better performance in loops, you can make use of generators. So they are one of the most useful tools in Python for handling big data efficiently. So try to understand the concept. This is not much of any confusion here. Try to understand, practice it. I'll try to also uh, provide you more examples on this in the material. Go through it. Yeah, thank you.